I showed you how to do pH and pOH and how to find the hydrogen ion concentration and the hydroxide ion concentration using formulas. I had a student that she was getting lost in all of that, so I drew this picture to see if it would help her. So if it helps you, then great, use it. If it doesn't, then don't worry about it. One thing you need to realize is that hydrogen ion is the same thing as hydroxide ion without the water. So if it tells you one of those, it tells you the other. Just assume they're the same thing. If it's a strong acid, which is really, we're going to assume they all are for right now, then the the hydrogen ion concentration is the same as the concentration of the acid. So if it gives you the concentration of that acid, it's telling you the H. If it gives you the concentration of OH, it's telling you the base. So once it tells you the molarity of the acid or the base, first of all, it's going to tell you the molarity of a substance, and you have to figure out whether it's an acid or a base. So if it starts with H, it's an acid. If it ends with OH, it's probably a base. And then you can follow the arrows as to what to do. Now, when you do those, remember that you have to do it in the right order. So let me just give you an example. Let's say it said, find just the pH of a 0.0015 molar, SROH2 solution. So if we were given that, let's see, maybe I should change colors here. Okay, you have to figure out whether this is an acid or a base. So because it has OH in it, it's a base. That means that the molarity that I just gave in that problem is telling me, oops, I missed a zero. Hang on a second. Okay, the molarity is telling me the OH concentration, so it's telling me this part. So I want to go this way because that's the only way to get to pH. There's no shortcut there. So you fill in for the X and you work from the X outward. So the first thing I'm going to do, at least on my calculators, is to put in 0.0015. And then I hit the log key. It's supposed to be log. And that gives me a negative 2.82. And I think just to simplify matters, I'm just going to have you use 3 significant digits anytime we're dealing with this particular topic, pH and OH and all that. If you just always use 3, it'll make it easier on both of us, I think. Okay, and then remember that chemists don't like to deal with negative pHs, so that's what this last little line means, is drop the negative sign or change the sign. So it was negative, so we make it 2.82. And then the 14 means that these two have to add up to 14. So take 14 minus whichever one you're missing, and that gives you the pH, which would, if I go to 3 significant digits, be 11.2. So that would be my answer. If I ask you for hydrogen ion concentration, then you would take that, make it negative, and do an anti-log, which on most calculators is a 10 to the X key. So you hit your, some people have to put the number in first, some people have to put the key in first. So mess around with your calculator and see which it is, and then do an anti-log. I'm coming up with 6.31 times 10 to the negative 12. And if it is on this side, and I'm going to erase all this because it's getting really messy. If you're on this side of this, I call it the C because it kind of makes the shape of a C. If you're on this side of the C, your label is capital M for molarity. If you are on this side of the C, you have no label. So take about 5 minutes, double check your work, compare with somebody. Do not copy, just compare and get it turned in, because you have a new assignment that has several steps to it, and it's got stoichiometry, and you're going to want all the time you can get on it.